of the circle, in this case of the circle, centroid of the circle, means that y bar is here b, here y bar is equal to b. Just we will substitute y bar as b. This is equal to how much? Area of the circle is now pi a square, which we have just calculated, into this is 2 pi into y bar, but y bar is, this is pi a square into 2 pi into b. Why b? Because y bar is b, length of the centroid, or distance of the centroid from the line. So this is y bar here. In this case, this is x-axis. This is how much? This is 2 pi square into a square into b. 2 pi square a square. This is 2 pi, 2 into pi square. This is 2 into pi square. Twice into pi square into a square into b. So this is the volume of the, because a square b is there, 3 dimension. I mean triple length is there. I mean q of a particular length is there. A square into b is the volume here. The volume of the that anchor ring generated after revolution of the circle about the straight line. This is the volume here. This is the first answer. 2 into pi square into a square into b. That is the first answer. Now second is surface area we have to find out. So what is surface area that we have to find out now? So surface area now it will be, let me find out that also. Surface area is now, let me, I'm changing the marker here. Okay, so let me now rub this. So this is first answer. Now second answer is surface area. Therefore surface area of revolution, second part, surface of revolution, surface of revolution generated by the revolution, in this case by the revolution of the anchor ring of the circle here, of the anchor ring, that is circle here, is equal to length of the arc into length of the arc here, circumference of the circle, because this whole arc is taken. Length of the arc here, the circumference. Here the circumference of the circle. Try to understand. Into here also circumference. Here circumference into of the circle generated by the centroid of the circle, in this case of the circle. Try to understand. So what is the circumference of the circle? Length of the arc, that means whole circumference, but twice into pi into a into twice pi into b, because y bar is b here. It will give us 4 into pi square into a into b. This is the second answer. So surface area of revolution, second, from second question, this question is obtained. So question number 3 is based on both the theorems of Pappus and Guldin theorems. These results are based on both those theorems of the Pappus and Guldin. So this is the first question we have taken based on Pappus and Guldin theorem. This is how we apply them. We just write that what is the theorem and what is the point here. What is the distance of the centroid? Y bar in this case was given b. So that is the point. Now fourth question, let me talk about. Now question number 4, what does it say? Question number 4 says the loop of the curve twice a by square equal to x into x minus a whole square revolve about the straight line y equal to a. Okay, find the volume of the solid generated. Now in this case volume only. First let me find what is the loop of this curve here. So question number 4, the loop of the curve. We are given the curve here twice a y square equal to x into x minus a whole square is revolved about a straight line. Revolved about, the loop of this is revolved about a straight line y equal to a distance away from the loop. Okay, that is the point given to us. Y equal to a away from the center of the loop, maybe from the loop. Now let me draw this. Let me first draw the loop. What kind of loop is this? Solution. Putting y equal to 0. So we get x into x minus a whole square equal to 0, or x equal to 0 and x equal to a. And if I put x negative in this case, then y square will be negative. It means beyond, for negative values, y square doesn't exist. Y square is negative. So for negative values of x, y square is negative. So curve will not exist. So curve does not exist for negative values of x. For negative values of x. Try to understand. So what kind of curve is this? So loop will be here. Beyond this, the loop does not exist. This is the loop here. This loop is of similar size. I'm sorry. This is of similar size here. This let me take. This is the loop here. This is x-axis. This is y-axis. Now it says that from the centroid of this. Now this is G also center. This is G point here, centroid. This says centroid of the curve is a away. This is y coordinate of this. That means this line is lying y equal to a distance away. It means this is a here, because this is y equal to a. Y equal to a means y coordinate of this line. So this line is there. About this line, this curve is revolved about. So this area is revolved about. First we have to find out the area. Here length is this here x equal to 0. Here x equal to a 0. But this is a here, x equal to a. So x equal to a 0. The curve meets the x-axis at 0 0. This is 0 point here. At origin. Beyond this line, the curve does not exist. So this ends here only. The loop is ending here. 0 to a limits are there. Try to understand. So first we have to find out the area. What is the area here? Twice the area of this O point, A point. Let me take here B point here. So O, A, B. This curve, if is revolved about this line, one thing. Secondly, if this curve, this total area we have to find out. So this twice of this area, because this area is above. If we find out limits from 0 to a, and this curve is substituted there, and then twice of this is there, because this area is also included. So total area of the loop, let me find out. Area of the loop. Area of the loop. Okay. Now this is meeting at a 0 0 a 0. That is clear. But from this a 0, if I put here a 0, y will be 0. Y is 0 here. So A0 and this curve is meeting the x-axis at 0, 0 and A0. Okay, that is clear. So the area of the loop in this case, area of the loop will be equal to twice into area generated by the arc OAB. OAB arc area of this, twice of that will give us this area also. We are not revolving this, but this whole area is revolved over this line. Okay, so the area first we have to find out. That is the area by the area. So this is twice into what is this area? Area generated by this OAB. This is limit 0 to A. Now this is pi into ds. Okay, this is 2 pi into ds. Because area, if we find out, and this is y into ds only, because this is not 2 pi into ds, because we are not revolving this. This is y into ds only. Length, if I take a point P here, this is b here, so y into this is ds. If I take a elementary strip, then this is ds here, and this is y coordinate. So y into dx only, y into dx. This is y into dx only. I'm sorry, y into dx only, not ds, but y into dx. This is area we have to find out of this arc. The area of this arc will be this much. All right. Now let me take what is the area of this. So that is the question number 12. Here we are calculating y into dx only. Twice into 0 to a. Twice into 0 to a y into dx. What is y here? Y is from this equation given. What is y here? This. Y square equal to that value. Okay, let me substitute here. So first we have to find out the area. So this area is twice into 0 to a. Y from first equation. This is first equation here. Here y is, let me solve it here. So y is square is equal to x into x minus a whole square upon 2a. That means y is equal to therefore x minus a under root x divided by under root 2a. That's the point. When we substitute this value here, it will be x minus a under root x into dx divided by under root 2 into under root a. No problem. That can be taken outside. It will be under root, because 2 upon under root, let me write first. 2 upon under root 2 into under root a into 1 upon under root a. 0 to a. This is x minus a into under root x into dx. Okay, now let me solve it above. Let me write here. So this is the area we are calculating of this loop. Then we will revolve it about this line. The distance of that line y bar is a here. We will then calculate. Okay, it will give us now 2 upon under root 2 is a root 2 in the numerator, because 2 can be written as root 2 into root 2. 1 root 2 cancelled out. This is root 2 upon root a. This is area we are calculating. Area of the loop, total loop. Area of the loop, this whole, is this. Okay, into a, 0 to a here. Now this is x into under root x. That means first is x raised power 3 by 2 minus a into x raised power 1.2 into dx. Try to understand. Under root x into a. Under root means a half power. There is a radical sign 1.2 power. Square root x means x raised power 1.2. So under root x into a into x raised power half into x into under root x. That means x raised power 3 by 2. Can be integrated easily. So this is root 2 upon root a into integration of this is x raised power 5 by 2 upon 5 by 2 means 2 by 5. Okay, minus sign. This is a 2a upon 3 into x raised power 3 by 2. This is 3 by 2. Limit 0 to a. No problem. That is the area. Let me further solve it. The area of this loop will give us, this is under root 2 upon under root a. We are calculating. 2 by 5, this is 2 by 3. If I take 2 outside, let me take 2 out, and this is a raised power 5 by 3. Sorry, 5 by 2, I'm sorry. Upper limit only, we can substitute because at 0 it is 0. So this is minus 2 we are taken, so a into a raised power 3 by 2, that means a raised power 5 by 2. This is upon 5. This is a raised power 5 by 2 upon 5 upon 3. This is upon 3. The same power because a into x raised power 3 by 2 and a be substituted in place of x. So x raised power 3 by 2 and x a raised power 1. 1 plus 3 by 2 means 5 by 2. Same powers are there. A raised power 5 by 2 if I take outside, so 2 root 2 into a raised power 5 by 2, and the denominator we are having a raised power half, that means minus a half, into 1.5 minus 1.3 in the bracket, it is left over. Therefore, the value is now equal to, this is 2 by 15. Why? Because this 5, 3 are 15 LCM. We have taken this is 3 here. Okay, so let me take this is 2 by 15. Why? Because 5, so 3 minus this. Negative value is coming. Okay, negative doesn't matter because area is always positive. Because if I take a to 0, then it will be positive. So we have to start from a to 0 limit because this curve loop is coming from this side. Okay, so that is 4 negative, doesn't matter. This is 2 by 15. We will take from minus 2 by 15 is okay, but negative sign is eliminated because limits are not from 0 to a, because a to 0 limits will be there. Then it is positive. So that is root 2 by 15. 2 by 15 into 2 root 2 means 4 root 2 15 into a raised power. Half is 4 by 2, that means a square only. This is the area now. What the volume therefore? Hence by Pappus and Guldin theorem. By Pappus, sorry. Pappus, Pappus and Guldin theorem. We have volume. Guldin theorem, the volume of the solid generated or volume of the revolution of this loop about this line, volume of the revolution of the closed curve, in this case loop, closed curve loop in this case, about a line at y equal to a is given by area of the loop into area of the loop here, sorry, area of the loop into area of the loop into circumference of the centroid of the circle of the generated by centroid. Circumference, it is circumference of the circle generated by the centroid. Circle is generated by the centroid. Now in this case, G is revolved about this line. This is L point. GL is A here. We are given. So that is, let me now write here. Therefore, volume is equal to area of the loop into circumference of the circle generated by the loop, sorry, by the centroid, generated by the centroid of the loop in this case. That means area is this 4 under root 2 upon 15 into a square into 2 pi into pi bar is here a, 2 pi a. where by bar is A, this by is equal to A, because GL is A here. Okay, here by bar is equal to A. This is 2 pi into A. What is the total value? Therefore, area is, sorry, volume in this case, therefore volume is 4 under root 2 upon 15 into A cube. 2 pi has also come out. It will be 8 here. 8 into pi. 8 under root 2 into pi into A cube. Let me write clearly. So this will be 8 root 2 into pi upon 15 into A cube. This is the answer here. The volume A cube. A cube is the unit here, undoubtedly of volume. So volume is this here. Question number 4 is thus calculated in this way. Okay. So this is question number 4. Applying Pappus and Guldin theorem, we can solve these kind of questions here. Now let us take question number 5 or fifth question. What does question number 5 say? Let me now check it. So question number 5 now. Let us discuss about. Question number 5. What does it say? Let me check it. Question number 5 is giving us, I would say, so that the volume generated by the revolution of the ellipse this about the line x equal to 2a. Now in this case, x equal to 2a line is given. So ellipse is there. What is the ellipse? Let me take this ellipse is here. This is the ellipse here. Here it is A. Okay, and this is A also. But this point is minus A and 0. This is A 0. Now here it says there is a line at x equal to 2a. So this distance is x equal to 2a away from this. And this is the ellipse. This is B point here. B point is 0b. This is 0 minus b. This is b dash. This is a dash. This is a point here. This is the. Okay, we can take this O point. Okay, so this is the O point here, center of the ellipse. Now we know that what is the area of the ellipse. That we know about. Area of the ellipse is given as pi into A into B. This is area of the ellipse. This we have done a number of times. Area of the ellipse of the standard area of the ellipse is pi into A into B units or square unit of what is the ellipse here, x square upon A square plus y square upon B square equal to 1. This is the area of pi AB. Now here x equal to 2a given. Is x equal to 2a at the distance x equal to 2a. No problem. That is x bar here. X bar is 2a. Yeah. About the line x equal to 2a. X equal to 2a. If it's okay, revolve about. That means x bar is equal to 2a. Same thing. The circumference generated by of the circle generated by this revolution of the ellipse about that line x equal to 2a. Okay, that we can then find out. So let me just write what is the volume of that. So volume generated by, we have to show that the volume generated by the revolution of the ellipse. This is question number 5 here. Here this ellipse is given. Here the ellipse is x square upon A square plus y square upon B square is equal to 1. This is first equation. Solution now. Just by applying Pappus and Guldin theorem, we know that what is area here? Area we know that pi a. If I calculate area, we can calculate minus a to plus a. We can take the sign here, and this is by into. If I take P point here, by into dx, we will take this is dx here. Okay, or if I take ds here, then 2 pi into dy into ds. Okay, then also we can calculate, and the y value we have to calculate from here, b square upon a square into that value. That can be solved in that way, but we know that this pi ab area of the, or if one has to calculate this, then we can take the whole ellipse here. What is the area of the ellipse? So for that, x limits will be taken minus a to plus a, or if I take only this arc, then twice of that 0 to a limits if I substitute, that can also be done. And then any point if I take here on this point and then substitute that point here, okay, taking x equal to a cos theta and y equal to a sin theta, we can also solve in that way. Okay, so then substitute those points here. Okay, so the area is this. So area of the ellipse we know. Area of the ellipse is equal to pi into a into b. So applying, and length of the centroid, this O is the centroid here, G, okay, of the ellipse. Length of the centroid, length of the length of the, we can say, or here circumference of the length of the circle, or circumference of the circle, length of the circle, or of circle, or the circumference of the circle, or the circumference of the circle generated by the centroid, circle generated by the centroid of the ellipse in this case, okay, is equal to centroid of the circle generated by the centroid of the ellipse is equal to 2 pi into, by in this case x bar, this is 2 pi into x bar is twice a into twice a, this is equal to 4 pi into a. Therefore volume of the, therefore the volume generated by the revolution of the ellipse, okay, volume of the solid generated by the revolution of the ellipse about the line at x equal to 2a is equal to area of the ellipse into circumference of the circle generated by the centroid, of the ellipse in this case, centroid of the ellipse, we can say centroid of it, that is equal to, let me write it here. So this is 4 into pi into AB, this is area of the ellipse we know, or we can calculate this also, doesn't matter, and this is 4 into pi, 4 into pi into A. I'm sorry, this is only pi AB, not 4. Area of the ellipse is pi AB, I'm sorry. Actually I was thinking about 4, this 4 here, 4 pi here, but this is pi AB only. Therefore total volume will be 4 pi square, pi into pi, into A square into B. This is the same area, sorry, same value, 4 pi square A square into B, 4 pi square A square into B. This is the same, hence proved. So same value we have proved here. Okay, so same volume is obtained, which is question of 5th here, 4 pi square A square into B. Just remember that the area of the ellipse is pi a into b. Pi a into b into circumference, we have just calculated 2 pi into x bar here. X bar is given here because x is equal to 2a. Length is not pi bar. In this case, x bar we will take. X bar is also calculated in the same way. Okay, this is x coordinate of the centroid. That is 4 pi a. 4 pi a into pi a b. That means this. So this is the question number 5. Now let me take question number 6. What is question number 6 say? Let me check it. This is not properly working. Okay, now question number 6. Let me now check it. Okay, so question number 6 is now of what kind? Let me now check it. Okay, question 6. Sixth question is, find the volume of the ring generated by the revolution of the cardioid. This is cardioid here. Cardioid r equal to a into 1 plus cos theta. About the line r cos theta plus a equal to 0. Given that the centroid of the area of the cardioid is at a distance 5a by 5 from the origin. Okay. Now question number 6 it says cardioid. What is the cardioid given here? Cardioid is r is equal to a into 1 plus cos theta. This is cardioid. Okay, and about the line because about the line is r cos theta plus a equal to 0, or because r cos theta is x here equal to 0, or x equal to minus a. Here x equal to minus a. With the cardioid, we know this cardioid is generated by revolving. Suppose this is O point here. Let me take this is cardioid is generated like this. Okay. This is x-axis we can take, or we can take initial line. This is O point here. This is y dash point here. This is okay. So here theta equal to 0, or here theta is pi, because if I put pi here, then 1 minus 1 is 0. It is 0 here, so it is theta equal to pi. Here theta equal to 0. Theta at 0 is twice a, total is twice a. What is centroid? So let me take this is a centroid here. Centroid is G. It says distance of the centroid from the origin. That O is the origin here. So centroid of the, let me